if you have any more questions. So I would now move on to our final speaker, Cristiano Degiorgis. So
hi
please
Jake.
welcome him. Hello,
Hi.
Cristiano.
How are you? Good, good. I hope you can hear me. Yes?
Yes, yes.
Okay, good. So let's start. First of all, I like to thank all the friends that spoke earlier than me, because I think they helped me a lot to introduce my talk. So basically, they talked about service mesh. They talked about. Can you see my screen? I'm sharing already. No.
Yes, we can see.
Yeah.
We can see it.
Which one are you seeing?
I'm seeing the one with a black window and a white window.
Okay, he's the one who's moving now.
Yes.
Okay, good. So as I was saying, I have to thank the guys talking before me, and because they started introducing concepts that we're going to see now to my presentation. First of all, the service mesh, but also Irina did a very, very interesting talk about asynchronous communication and also alternatives to HTTP. So that's also part of the talk that I'm going to do. So thanks for the introduction. I think it's been very useful, maybe to make easier to understand the talk if the guys attending are not previous experience on those topics. So I don't have any slide. I just try to recap some points and try to have more room for the live demo. So tonight we are going to talk about CRD and operator. I mean, we are talking about Kubernetes, and we are talking about how to Kubernetes can be extended leveraging the CRD, that are the custom resource definition, and the operator are probably one of the most popular way to using these CRDs. But let's start from the very beginning of the journey. So Kubernetes is usually known as a container orchestrator, but in my opinion, this is a limited definition, because I used to define it as a framework for orchestrating containers. The fact that it is a framework means that it can be extended, and the way to extend them are these CRDs. Extending Kubernetes via CRD means, in fact, extending the API server, which is the core of Kubernetes. So the CRD, the custom resource definition, are first of all a resource definition, same as any other built-in resource in Kubernetes. Anytime you have to deal with Kubernetes, for sure you are familiar dealing with pods, secret, volume, and all these standard resources. The custom resource definition are nothing but resources that Kubernetes doesn't know at the beginning, because they are resources that you are defining, and leveraging on these resources, you can extend the API service in Kubernetes, having dedicated endpoint for managing your custom resources. Tonight, we are going to see two types of custom resource definition. One is the one related to let's say, the business app, the to-do CRD, which is the very beginning of this journey. It's basically a way that I use to start learning this Kubernetes extensibility, and I decide provocatorily to have a standard application, a standard to-do app that is exposed on HTTP to external partner, that as any application that you wrote in the last years, you need for sure a backend, a database to persist its own data, and eventually, if it's a part of an ecosystem, it also needs a way to, as Irina was explaining, leveraging the message broker, a way to communicate with other component of your solution, the fact that its own resources, in this case the to-do, can be shared with others in case other applications within its ecosystem are interested on knowing something about the specific resource that belongs to another component. And this is, again, the provocatory usage of the CRD, something that I suggest you to do not just try, do not share it with anybody for real usage. Just try it at home, and don't try it at home, so forget it. It was just for the sake of experimenting the CRD and the extension of the API server. Instead, also, as a tail of the discussion, we are going to see a real usage of the CRD, which is the one is named in the repo Kubernetes as backend, is the CRD related to the operator. leveraging the CRD, you can, as I say, extending the API server. If you simply use the CRD, which is nothing but a YAML definition, same as the definition of any other resources. If you simply build this YAML definition of your of a given custom resource, of course you have to follow the syntax required by Kubernetes. But after you wrote it, just with a simple YAML file, and you deploy in Kubernetes, you are going to get for free an API, an endpoint that is able to receive this resource and perform all the CRUD operation against that resource. So you can persist a resource in the internal Kubernetes storage, which is etcd, and Kubernetes is going to give you for free also the check of uniqueness. I mean, because it's basically etcd that is providing that feature, so you cannot persist within a namespace to resources with the same name. But that is the only feature that you get for free without writing any code. If you want to write code that react on this resource, you have to write a controller, and then the controller is nothing but a component, an application that runs within the cluster, and it will react anytime the CRD will be persisted in the etcd. In order to write in code for the controller, once you have the CRD, there are tools like the code generator in Go that I use for my prototype for the to-do app side, the business app side. There are utilities that, starting from the definition of the YAML, is going to basically produce all the strong type in Go describing the type itself, and also all the client set that is needed to interact with the API server. Let's see now briefly the diagram of the business application. So the business application, again, it was a provocatory usage of the CRD in order to provide a backend for my business application. So this business application is nothing but a very simple API that expose to-do endpoint. It will receive from outside a resource, a business resource describing the to-do resource with the bare minimum data, like the message related to what has to be done as a to-do, and the date, and the date when the to-do has to be accomplished. Then I decide to do not, as usually a wise person will do, I decide to do not have like a storage, a dedicated storage for this application. Usually you will spin up a Mongo or stuff like that, or a SQL Server, in order to persist those data. And also, if you have to share this data after it's been persisted in your storage, you usually use a message broker, as Irina was explaining, if you have to share these resources with other applications within your solution. Instead, I decide to use Kubernetes itself to do all these activities. First, to store the data, and second, also to share it with other applications running in the same ecosystem. Since we were already in Kubernetes, I say, why I have to bother to have a dedicated storage and a dedicated message broker to do something that Kubernetes can provide me for free? Okay, as I say, do not try it at home, because maybe if you have a huge throughput on your application, it might basically use Kubernetes just for doing that. But you have all the capability are available out of the box in Kubernetes, and let's see how. Okay, basically this application, you will expose an endpoint. Okay, now we have all the Kubernetes plumbing to have it, to make it happen like any other application that you deploy in Kubernetes. So this is our business application to a service exposed to an ingress and blah, 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 expose the endpoint to the third party make a request. This REST API, it will receive the request, and instead of saving directly in its own dedicated storage, it will map these external resources to the internal custom resource object that is based on the CRD, and that we previously deployed in the cluster, that allows to persist the business data. It will be mapped to the CR. And then, since you previously deployed the CRD, now the API server exposes a dedicated endpoint for your custom resource. then we are persisting the data collected from outside to the API server in etcd. At the moment, we are calling the API server, leveraging on the webhooks, which is a feature provided out of the box of Kubernetes that allows you to write your own validation. Once a customer resource, it will hit the API server. So basically, once the request will be performed from outside, the application will map it and will send the request to the API server. The API server, since you register your own webhook, it will be engaged as soon as a resource will be received for any CRD operation, create, update, and blah, blah. Since I decided to have all these components that are completely business unaware, I decided just to use it in this case as a pass-through. Basically, I receive that will be engaged by the API server, and in order to perform the real business logic, for example, what is the criteria rather than the uniqueness of the name to be accomplished before accepting this CR, I'm going to call a dedicated endpoint within the to-do app that it knows the business logic to accept or not the resources. I do it to a REST endpoint API because I'm more familiar and it was easier for my prototype, but probably the best way to do it is the one that Irina was presenting using gRPC, because since we are within the cluster, it's definitely the best way to perform an internal call. It's more reliable, faster, and it's definitely, there is much less overhead than the REST API. So I didn't implement it yet. Maybe I can be in touch with Irina and we can extend it together and having this gRPC endpoint. But again, the concept is the same. So we're just forwarding and calling the business. Once the admission webhook says, okay, things are good, then the API server will really persist it in etcd. Then once anytime a resource is stored in etcd, leveraging on the client, on the Kubernetes client, you can run an application that is named, I run it a component within the same pod hosting my business application that is called the informer. The informer is one of the components of the Go client that allow to listening all the changes that are occurring in etcd. Basically, once the data is persisting in etcd, leveraging on this informer, you can receive the notification that something changed. Now, for the sake of the demo, I have the informer running as a sidecar within within the to-do pod, but just because I was lazy and I didn't implement the second pod, that has also more sense in terms of use case. Usually are other applications that are more interested on what happened, not the application itself. Okay, I think that is at least give you an overview of the business side of the application. And now let's go back to the agenda and let's see. So now we discussed that, and then because this application it's a dummy application, it's pretty dummy, but it's pretty complicated. So it's nothing complex, but it's complicated. There are a lot of resources involved in this prototype. At the very beginning, when my initial goal was just having this application in place, I started writing standard plain YAML, bash script to perform the deployment, and also performing the certificate provisioning, because one of the complex part at the beginning was basically providing all the required certificate to register the webhook in order to be properly contacted by the API server. So at the end, when I have the first MVP of this business crazy solution of using Kubernetes as your backend, I end up with these resources and with all dependencies. So, and as I say, the complex part was the managing the certificate. Yes, it's doable doing with plain YAML, with bash that are using YAML and doing calling OpenSSL for generating and validating certificate. But again, it was pretty complex. And so I at that point, I say, why do not use something that is helping to deploy the application, but not just deploying the application, also making sure that all dependencies were successfully respected, and eventually also to monitor the application once after it's been deployed. And that's I start digging on the concept of operators. Or the operators is a Kubernetes pattern that allows to do everything that I just described. Basically, allows first to deploy the application easily, ensure that all dependencies with your application are respected, and also monitoring and observing that the status of your application, the state of your application is consistent. And if anything, of course, and is going to break, is going to change the desired state of your application, the operators, it will compensate, trying to rematch the desired state. Just to make an example, it's the same philosophy behind, for example, Terraform. Terraform does the same approach for the infrastructure. The operators does the same approach for your application. So, especially in a complicated solution, having an operator is basically okay. You have to put effort on writing the operator, but once the operator is done, basically you have nothing to care about as long as the operator is being properly written. Okay. So the operator, in fact, they are exactly what a human operator usually should take care of it: deploying application, monitoring the application is doing well, and intervene in case there is some issue with the application. So the operator are nothing but an application that acts as a human being, performing DevOps activity in your company. There are different ways to use operator. You can create your own operator just leveraging on the standard built-in Go client, because at the end the operator is nothing but informer and client set and typed API. But you are pretty good and in order to using just the raw foundation. Otherwise, you can leverage on some frameworks, such as, for example, the one that I use it for this demo, which is Operator SDK. That is done. It is not reinventing the wheel. It's using the internal Kubernetes components, starting from the client Go, and also the informer and all the controller utils, in order to provide you a easier experience, when you have to write this application, because the operator is nothing but an application. It's not an application that has a business effect, but it's an application that is aimed to support your business, the business application. I use Operator SDK. Basically, using Operator SDK, you have three approaches of writing an operator. One is leveraging on Helm. Basically, is the easiest one, but is the one that you can do less, because you are basically writing your Helm chart for deploying your application. You are packaging this Helm chart within an image provided by Operator SDK. And what the Operator SDK does for you is basically verifying, is deploying the Helm chart, same as if you deploy the Helm chart, but is ensuring that the Helm chart and all the resources that has been deployed leveraging the chart are respecting the desired initial state. So it's like having someone that periodically it runs your Helm chart. Otherwise, if you use Ansible, but I'm not going to discuss Ansible because I have no clue how the Ansible part works, but using Ansible or using the Go, programming the operator in Go, you have the full control on what you are like to do, because at the end you are writing, especially in Go, an application itself. And that's what I did for this example. Okay, Kubernetes. Yes, we discussed that you can use primitives or leveraging a framework. Then why Golang? So I decided to use a Golang a framework in Golang for writing the operator. Now other framework for operator are showing up on the market. For example, I have a colleague that basically wrote an application very similar to the one I did, leveraging on the C# client for writing the .NET Core one. The advantage of using Golang that you are at the same level of the Kubernetes itself, because the problem of other client or other framework written on top of the other language client is that they will never be up to date, same as the Go client. Why? Because the Go client is also using itself within the specific version of Kubernetes. something you can try. So there are basically the CRD and the related application and the usage of CRD operator and stuff like that is basically also what is behind the serverless approach in Kubernetes. For example, Kinetic solution are really about that. So basically you can, let's assume, this is the example you always use. Let's assume you have a component that does image cropping. Okay, if image cropping is your main feature, you have to run it permanently within the cluster. Otherwise, if you use image, you need to crop an image once in a while, it's going to be a waste having an application sitting in the cluster doing nothing and just be ready once another application within your solution requires an image to be cropped. So a good way to using CRD and operator is eventually when you receive the request from an application to perform an image crop, you might spin up leveraging on a CRD, an operator that will be available just to performing that operation when it's needed. And then same as you spin up, you spawn the container and the application with the CRD, you can destroy it as well. So, and then you don't have footprint in the cluster for nothing. Okay, so talk is over. Then I will switch to the demo. Okay, so demo. I had there is a lot of documentation at the very beginning. I start performing all the talks and all the demo in using kind as the cluster, so you don't need to use fancy cluster for this demo. Everything can be done in kind. The reason why now I switch and I run this demo today on AKS is because I'm using a very old Mac, and the last time that I tried to do this demo using some online platform for broadcasting the code, basically my Mac was sitting down and was not able to perform. So in order to avoid another epic failure in the demo, I decided to use AKS. But again, it's totally not needed. You can do all the sample that you can get from my GitHub repo that you can find here without needing to pay anything rather than the cluster that runs within kind. Kind is awesome. Just I'm not going to, so we need just a talk only for kind. Kind is a way basically to run Kubernetes in Docker container that runs all locally in your machine, leveraging the same Docker engine that you use on a daily basis. Today, instead, we are going to run the demo in AKS. So I already spin up several cluster, and I had one that I already provisioned the cluster. So I just to save time, I already did this step. I provisioned the cluster. I'm using a different DNS name for this demo. I'm using as a DNS demo Sintra that is going to be the final endpoint that we are going to use for the demo. The cluster has already been provisioning, and this is basically an endpoint that I'm using just for testing the ingress controller. Now in the cluster there is nothing but all the plumbing that is basically the ingress controller. So let's start some okay, let's say for example okay, we are just an internal namespace and the chart manager, because I had to use the chart manager to have Let's Encrypt provide me a HTTPS certificate. I'm using the staging version, so if you want to try it, or you switch to the non-staging, but I strongly suggest to not do it unless you go production. I use a staging version of Let's Encrypt. You just have, in order to have a full experience with the browser, you just have, as described in the demo, you have just to install the certificate authority provided by Let's Encrypt in your key store. Then, but as you can see, there is nothing business. The default namespace, it contains, right now I'm in the default namespace, it contains nothing but the two pods that I use to verify that the container is up and running, are the echo container provided by HashiCorp, just to do a very dummy output and proving the ingress is working. What we are going to do, we are going to execute the next step. Let me start it and then I will describe it. It's just the script is just containing a bunch of commands. Now we are going to let me first execute it, and then we can move while it's working. Okay, it won't take that long. Let's just browse together what it does, this script. So what it does, it basically installing the CRD, okay, the one is needed for the operator. The one that is needed for the business application instead will be deployed by the operator itself. Because as we say, the main goal of the operator is deploying the entire application that we described, all the component, all the business component, the technical component like the informer, but also provisioning all the certificate required by the webhook and registering properly the webhook in the API server, and all the scenario that I just described. Now, the second step, I will just create a dedicated namespace for running our operator. Then we have to do some RBAC. Since the operator is an application itself, in Kubernetes, any application requires RBAC in order to grant permission, sufficient permission for the operator to run, same as any other application. Then we deploy the operator. This step is just deploying the operator itself. After the operator is deployed, it will do nothing until you send the related CRD, the related CR, the custom resource that is the one defined as the CRD related to the operator. So basically you are telling to the operator to spawn an instance of your entire application. Anytime we deploy a CR, which is like this one, it is, let's browse it. It's very stupid. This is just a CR that say basically I want to have all the solution that I have, all the pod and the informer and all the container, the multi-pod container. So all the components that I brought are to a given version, and I just make sure to the CR that all the component of the same version are used for a given release of the product. Then this site is just for the sake of do something. Is basically the same example you can get from the operator SDK. It allows you to scale the to-do application, but this is totally up to you what you want to implement code-wise. Okay, so that's what is being performed by the last step. So basically, first we do all the plumbing, we deploy the operator, and then we tell the operator, okay, please spawn a full solution. After that has been done, now we can see that first of all, we should have a new namespace that is the one hosting our application, and because of the command that I use in the kubectl, it also switched to that context permanently. So I don't have to explicitly target a given namespace. Then, if we say get pod within that namespace, we're gonna have three things. One is our operator, and once after the operator has been deployed and we deploy the related CR, it starts spawning all the components related to our business application. It is the to-do app, okay, the one we were browsing, we described it here, and the other one that is the admission webhook. Here you can see that this to-do app, it has three components. So two, you can see it. One is the business one, the other is the informer. The third one is, because I'm super lazy, there's a third component that is basically a component that is hosting the kubectl itself and doing kubectl proxy within that container. It's very easy to browse, to interact with the API server, because it's not a direct connection, but it's basically going from the to-do app to the kubectl container that runs kube proxy, and then I can contact on the local host the API server. So it's basically just a lazy way to contact the API server. Okay, thanks to all these plumbing, now we can go to the related web application for this for our demo, and we start from this that is just containing the basic endpoint for the ingress, and then I copy another cluster that is running. We just change the DNS, matching the DNS that we use here. No, it's not this one, it's this one, simple, okay. This is the, okay. And now we have our application up and running. Since it's the first instance within that cluster, if we try to get the to-do, we're gonna get nothing because we don't have any to-do yet deployed. Now let's deploy a to-do. Basically, this is the endpoint that is exposed externally. Okay, this is just the interface from the client. And as you can see, is the minimal one. It doesn't have all the complexity that is needed by the CRD itself. Okay, but here we can perform this operation. We are calling the endpoint, sending this payload, and then executing. We're gonna have a 200. And now if we are going to execute the search, we're gonna have we're gonna get some data, same as you get data from a standard endpoint. Let's create another one. Okay. Did I create it or not? Okay, you get 400 because I already executed. That means if you try to execute twice the same request with the same code, as I told you, you get an automatic failure. But right now, calling again the to-do, we get 2 resources, the one that we just created. I also expose a fake endpoint, I mean, an internal endpoint, just for browsing them. This endpoint, this API to do notification, is the endpoint used by the informer to notify the business app anytime a resource has been persisted in Kubernetes, in etcd in Kubernetes. Then this is the endpoint used by the informer, and this is just an endpoint for browsing the result of the notification. And as you can see, we have 2 that are the 2 that we just processed. Of course, this will be more useful for another application, not just for itself. For itself, it's just an acknowledge that the data has been successfully persisted in etcd. I think this is it. We can basically deploy we can also deploy, let's do it live since we can deploy another instance within the same namespace using a different resource. So the second resource is going to be nothing but the previous one, just with a different name. And then we can deploy it in the same namespace, which is probably an option, but we're going to have another fully separate and isolated application running on the, I have to do the 2. Okay, now if we say Kubernetes get po, you will see another full stack that is going to be deployed and created. So you have to do nothing. Once this operation will be fully finalized, okay, we're going to have another application running on to a different segment that is basically this one. You can do the same. Right now there is nothing until our application will be completed, but once everything will be properly deployed, you can get also this additional endpoint up and running. You can do it in the same namespace, you can do the same resource in a different namespace. It's totally up to you. Okay, so this is a very easy way to deploy easily and fast a complicated application without having to take care of the deployment of each component. But on top of that, also for monitoring, because for example, if I go to kubectl and I try to destroy, to kill a pod, is the deployment itself that will recreate. But if I'm going, for example, destroying a deployment, and nothing will happen unless there is a guy that is redeploying the deployment. Instead, leveraging on the operator that is running in the cluster, is monitoring the entire solution. If I try to kill the deployment monitored by the operator itself, it will redeploy it, because he have to is trying to match the desired state. Now, the application seems now okay. And if we go here, we should now see that is up and running, another instance. I probably scrub something. Yes, I forgot the slash. Okay. Now we have another application up and running that is partially independent, because I was lazy. Since they are running in the same namespace, you can also see the the result it will provide you basically the other two, but just because they are running in the same namespace. If you do, I have to modify the code, but it was not having a reliable solution. It was not the goal of the demo. It was just the way to explain. Instead, if you run, of course, in a different namespace, they will be fully isolated. Okay, this is it. I hope you enjoyed.
Yeah, Cristiano, I see there's a question saying there are a lot of toolkits around CRDs operators.
Yes.
Any suggestions on good tooling?
Yes. Let me. Sorry, I'm not seeing the question.
It's on the chat. John asked it. There are a lot of toolkits.
Okay.
Can you see it?
Chat. Yes. Wait.
That's the last
yeah.
message.
Okay. So you say there are a lot of toolkits around CRDs operator. Any suggestion on good tooling? Yes. So, for example, so if you are brave and if you are very good and brave, as I suggest, you go with code generator. That is the one that I used for my initial, let's say, business app. In the business app, I built all the scaffolding for the types, for the informer using code generator, which is a Go tool. If instead you want to have a more relaxed experience on writing the operator, I decide to use Operator SDK, that I think is a pretty good and solid framework. The main competitor that are today are no longer competitors because they are going along each other, are Operator SDK and KubeBuilder. The latest version of Operator SDK also requires KubeBuilder, so they are getting very friendly each other. So I think that those two at the present in the Golang and landscape are probably, in my opinion, the best tool for writing operators, if you want to code it.
Yeah, that's fantastic.
Just keep in mind how simple is leveraging on this framework. That when I start building all this stuff, I have no previous experience in Go language either. So I learned Go, and then once I learned Go, I also learned how to writing operator. But then it was easier to level so the learning curve of Go was less complicated rather than if you have to write it from scratch, leveraging on the great tooling that you have in the Go environment for managing Kubernetes. So the effort of learning a new language is going to pay you back for sure if you want to play nicely with Kubernetes.
Yeah, that's fantastic, Cristiano. Thanks for answering questions, and thanks for sharing your knowledge, and thanks for sharing the demonstration as well. It was very interesting. And yeah, I would like to thank all speakers, all 4 speakers. They made this event possible. Are you not finished, Cristiano? Sorry.
No, I'm finished. Just a closing note. As I wrote at the end of my repo. So if anyone is willing to collaborate and improving my repo, is more than welcome. So all this stuff is really not for trying for real. But I think if you are mastering this concept, basically I just shared the journey that I did on this concept. They are definitely help you to use the real stuff around this concept. For example, now on Microsoft Word, DAP is becoming very popular and is addressing all this concept in a professional way. So, or you can try, as I did it, just for the sake of experimenting. Then if you want to do for real, go for DAP or other frameworks that are around service mesh and operators. And it will be easier for you to use this tool if you get the basics step by step, as I did. That's my personal suggestion. And
yes.
No. I'm stopping.
Okay. That's fine. That's wonderful. If you have anything else to say, feel free to, Cristiano, obviously. If you want to share something else. That's more than enough.
Okay, cool.
Yeah, thank you for that. That was amazing. And yeah, thanks, Johan. Thanks, Cristiano. Thanks, Irina. And thank you, Leonardo, as well, for making this event possible.
Sure.
I would also like to thank Simpra for sponsoring this event. And yeah, as always, Tech Italia is an open community, so feel free to make any suggestions on future topics or propose as speakers if you know someone who would like to participate. If you know any company that would like to partner up with us or sponsor any events, please do get in touch. And yeah, I hope to see you soon again. You will receive an email in the upcoming days with all the information on speakers and the screen recordings. So yeah, thanks again.
Thanks, John. Thanks for having us.
Yeah, it was great. It was great.
Yeah. Thanks, everyone.
Yeah.
Bye bye.
Thank you. Okay,
Bye.
have a nice dinner.